Good morning. We are on 6.015 today for Pre Calc, and we're going to be talking about law of cosines and some of its applications. Last time we talked about law of sines in the ambiguous case, and law of cosines is going to be used whenever you can't use law of sines. So I've been having a little bit of trouble. I don't know if it's my computer or internet or this program, but it seems to work better if I have I don't know if it's less writing or when I upload the document. So what I did was I used my typed version. So as you need to, you can just pause and write down the problems in the video. And if you would prefer, I'll post a blank copy. So if you prefer to print this out, you can do that as well. All right, so for law of cosines, your formula is going to be a squared. So this is for triangle A, B, C. So the angles, remember, are capital letters, lowercase letters are the sides. So side A squared equals side B squared plus C squared minus 2 times side B times side C times the cosine of angle A. So you only need one angle here. So to decide to use law of cosines, you would first ask yourself, do I have a side across from a given angle for law of sines? And if the answer is yes, then you use law of sines. If the answer is no, that's when you want to try to use law of cosines. And law of cosines can be adapted to, of course, any triangle with any letters. So it doesn't have to be angle A, B, and C. It's just saying that this is a side squared equals the other two sides squared minus 2 times those two sides times the cosine of the angle across from the side that you set it equal to. So you can also adjust this for any side of the triangle. So take a moment here and pause the video and try to write down for letter A, set this equation equal to B squared instead of A squared. All right, so really it's just kind of switching the A and the B. So now you would take side A squared plus side C squared minus 2 times side A times side C times the cosine. So this time, since we set it equal to side B squared, we'd find the cosine of angle B. All right, now pause the video and try setting it equal to side C squared. And that one, we would take our A squared plus B squared minus 2 times AB. And this time, since we set it equal to side C squared, we would take the cosine of angle C. Notice it's cosine here, law of cosines. All right, now let's look at some problems that we can use this in. So find the measure of angle B of triangle ABC. And I'm just going to draw a picture to get an idea of what we're talking about here. So here's triangle ABC. Side A is 8. Side B, that's lowercase b, across from angle B, is 19. And side C, lowercase c, across from capital C, which is the angle, is 14. Round to the nearest tenth where appropriate. So you'll notice here, I am looking for angle B. I do not have any given angles, which means I can't use law of sines. Because in order to use law of sines, I need to know one angle and I need to know the length of the side that's across from it. So here's a good place where we can use law of cosines. Now, since I want to find angle B, looking at your formulas, they only use one angle. So if I'm looking for angle B, right here is the only formula that actually has angle B in it, which means if I'm looking for angle B, I want to set it equal to side B squared. So I'm going to use B squared equals A squared plus C squared minus 2 times AC times the cosine of angle B. And now I'm just going to substitute in. So I've got B squared, B is 19 squared, A is 8 squared plus C is 14 squared minus 2 times 8 times 14 times the cosine of angle B. So we're solving for angle B, which means we need to get that isolated. We can't separate it from cosine here, so we really are trying to get cosine of b to be isolated first. So how do we do that? Well, a lot of work in our calculator, but also remember that this right here is all attached with multiplication. So when I go to my calculator, I can type in these we can just fill in first. So 19 squared would give us 361, 14 squared would give us 196, or 8 squared we started with. 8 squared is 64, plus 196. Now here, I can multiply this 2 times 8 times 14, which would give me 224. Now, one of the most common mistakes here is for students to do 64 plus 196 minus 224. And the reason you cannot do that is because 224 is attached to the cosine. So these three things are not like terms. These two are, because they're not being multiplied by anything else. So we can go ahead and add 64 and 196 to get 260. And, really make a note here because that's really important. Again, you cannot add all three of these numbers. You can add these two. And again, we're trying to isolate this cosine b, get it by itself. Think of it as like an x. So what do you have to do to get x by itself or cosine of b by itself? Well, first we're going to need to subtract our 260. We always add or subtract anything that's around it first. And we get 101 equals negative 224 times the cosine of b. Now we can try to get cosine of b by itself by dividing by negative 224. And that gives us a long decimal. So we're going to type that right into our calculator. So we'll do 101 divided by negative 224. And we'll write out that decimal. So I've got the cosine of b equals negative 0.50892857. Now I have cosine of b by itself. I need to get just b. So b we know is an angle because it's next to cosine, sine of an angle, cosine of an angle, tangent of an angle. So how do I find that angle? Well, remember in your calculator, and I want to be in degree mode here, which I am. And I want to do, whenever I'm looking for an angle, I'm going to do second sine, second cosine, or second tangent. So since I have cosine, I'm going to do inverse cosine. I'm going to go up here and grab this and then hit enter. And that is my angle. So I write out the entire decimal first. And then this says to round to the nearest tenth. So 116.8 degrees. Now, whenever you're looking for an angle, you have two possibilities, right? So cosine here is negative. We know cosine is positive in 1 and 4, which means it's negative in 2 and 3. Well, 116 degrees is in quadrant 2. If I found an angle in quadrant 3, I know this right here is 180 and this is 270. If I found an angle in quadrant 3, that means it would be between 180 degrees and 270 degrees. This angle, angle B, is part of a triangle. Can I have one angle in a triangle that's more than 180 degrees? No way. So I cannot have an angle in quadrant 3 that's part of a triangle. Also can't have an angle in quadrant 4 that's part of a triangle. So if cosine was positive, you also would only take quadrant 1. So this one makes it a little bit easier than sine because you don't have to worry about those two different possibilities. Okay, number 3. So these get a little tricky with the force problems. So two forces of 30 newtons and 40 newtons act on an object. The resultant force forms a 59-degree angle. So the resultant is just your diagonal. And whenever you see these force problems, I want you to be drawing a parallelogram. So let's start off with our two forces, and we'll finish reading all the information. Okay, so I'm going to make this into, these are my two forces. Always have them intersect at the bottom left. And let's label. So let's make this our 30 Newton force and this our 40 Newton force. So in a parallelogram, opposite sides are the same. So this is also 40 and this one's also 30. The resultant force, so I said the resultant is your diagonal. I always want your diagonal going from bottom left to top right. It's going to form a 59-degree angle with the force of 30 Newton. So it's hard to kind of read these. You have to read a couple times to figure out exactly what you're being asked to do. So the resultant, this pink line right here, the diagonal, forms a, actually let's label that, forms a 59-degree angle with the 30 Newton force. So here's the 30 Newton force, and here's the resultant. It says the resultant forms a 59-degree angle with the 30 Newton force. So that's the angle that would be 59. And of course, you can always trace those things if that helps you. Find the obtuse angle to the nearest degree between the two given forces. So what we're looking for is the angle between the two forces. So between the 40 newtons and the 30 newtons, we're looking for that whole angle. So if I want that full angle, if I can just find this little extra piece right here, I can add that to 59 and that'll give me the full angle. All right, so let's see if we can do that. Let's call that little extra piece here X. All right, so now I'm going to focus my attention on one of these two triangles that the parallelogram is split to. And oops, it didn't change. And I'm gonna, doesn't want me to use that. There we go. I'm gonna look at this bottom triangle right here. So one triangle at a time. Now something else that I can label here is I have 59 degrees here in a parallelogram. Opposite sides are parallel, so you have all interior angles here. So this angle is also 59. And this one would also be X because of all interior angles. So now, again, I'm looking at that yellow triangle. I have one angle in it is 59 degrees, and I know two sides. You want to also take note here, because this is a very, very common mistake before we actually go ahead and find it, that X is not 59. Those are not equally divided, those two angles. And the reason you can tell that is because your two forces aren't the same. So you didn't create an isosceles triangle here. If this was 40 and this one was 40, then both of those angles would be 59 because it would be an isosceles triangle, so the base angles would be equal. These are not equally divided, so you cannot assume that that angle down here, X, is 59 because those forces are not the same. Okay, so now let's get back to finding X. So here in the yellow triangle, I always ask myself, do I have a side, a given side, and I know the angle across from it, or do I know the given angle and I know the side across from it? So here I don't know X, so that can't count as my angle. The only angle I know is 59. So do I know the side across from the 59? And I do, it's 40, which means I can use law of sines. So I'm going to set up my law of sines now. So I take the side 40 over sine of the angle across from it, which is 59, equals 30 over sine of X. Okay, so now we're going to solve. So let's cross multiply. When we write that out, remember to make sure you write the number in front of the sign. So 30 sine 59 as opposed to sine 59 times 30. And 40 sine X. Very important. Those are written in front of sine. Now I'm going to solve for sine, so divide by 40. And type that right into my calculator. So I'll do, I can write it right as alpha y equals, or you can type it straight in. So 30 times sine of 59. Again, make sure your calculator is in degree mode. And divided by 40. And we get that decimal. You want to write that out. 6428754,755. And then we're looking for an angle again. So how do we find a missing angle? Well, we go to our calculator and we do second sine, second cosine, or second tangent. This is sine, so I take second sine, arrow up, grab my last answer, hit enter, write that out. So inverse sine of our answer equals 40.006572218. Now, anytime I'm looking for an angle, I would have two possible angles. So sine here is positive. So I would take 180 minus 180 minus 40 to find it in quadrant 2. So let's just see what happens here. 180 minus this angle right here. Okay, so that would be my other option for x. Now in x, I already have a given angle of 59. So if I were to add 59 to that angle, I get 198. That's bigger than 180. So can that be a part of that yellow triangle? No, because when I add it with 59, it gives me an angle bigger than 180 degrees, and I need a third angle still. And I am already over 180 degrees. Remember, angles in a triangle have to add to 180 degrees. So we will use quadrant 1. So here you're going to reject quadrant 2 angle. And actually, let's write a reason for that here, because I know some of you get confused there. Because would be greater than 180 degrees when added to 59, the other angle in the triangle. All right, so now it asks us to find the obtuse angle between these two vectors here, the 30 newtons and the 40 newtons. So I'm going to take my answer, which was x, and add that to my original 59 degrees and write out that whole decimal. So in your calculator, I'm just going to arrow up here and grab that 40, add it to 59, write out that entire decimal, and then it says to round to the nearest degree, which would be 99 degrees for your final answer. Okay, so big things to remember here. Parallelograms you should be drawing anytime you see these force problems. So if you have got two forces, draw a parallelogram. The resultant is always your diagonal. Always draw this in the same way. So always put bottom left to top right for your diagonal. Let's try another one. Two forces are applied to an object. So as soon as we're seeing forces, we should be thinking parallelogram. The measure of the angle, actually, let's even draw that right now. So we've got two forces. The measure of the angle between the 30.2 pound applied force and the 50.1 applied force, and the 50.1 pound resultant is 25. So that's a lot to read. Let's try that again. The measure of the angle between the 30.2 pound applied force, so I know one of my forces is 30.2, and the 50.1 pound resultant. So 30.2 pound applied force, 50.1 pound resultant is 25. What are they saying is 25? Read it one more time. The measure of the angle between the 30.2 pound force and the 50.1 resultant, so the angle formed between these, is 25. So that's 25. Find the magnitude of the second applied force to the nearest tenth of a pound. So we're looking for this other force. Using this, so let's stop there and actually find it. So first, again, I've got some things I can label. I know opposite sides are equal in a parallelogram. I also know opposite sides are parallel, so these all interior angles will be congruent. So this angle's also 25. And I'm trying to find x. So I look here and say, do I have a side across from a given angle? And the answer is no, I do not. So can I use law of sines? The answer is no. Again, to decide that, I'm looking at one triangle. So I'm looking at this bottom triangle here, saying, okay, I know 2 out of the 3 sides. I know one angle, but it's not the angle that's across from the 2 given sides, either of those. So let's use law of cosines. So when I'm solving law of cosines, I want to find x. So I'm going to set law of cosines equal to x squared. So you always set it equal to the side you're given or the side you're looking for. So you would set it equal to the side you're looking for if you don't have the side. If you're looking for the angle, for an angle using law of cosines, you would set the equation equal to the side across from the angle that you want. All right, so now we've got 30.2 squared plus 50.1 squared minus 2 times 30.2 and 50.1. Just acting up again, I apologize for all the extra lines, times the cosine of 25 degrees. All right, so now when you have the angle that's given to you and you're looking for just this left side of the equal sign, type that whole thing in your calculator at once. Type in calc at one time. Okay, so go to your calculator and you're typing in, and make sure you're in degree mode because we're given the angle in degrees. So 30.2 squared plus 50.1 squared minus 2 times 30.2 times, not minus, 50.1 times the cosine of 25. Enter. Write that whole decimal out. So x squared equals 679.5263841. And now we're solving for x, so you're going to take the square root. And anytime we take the square root, we have plus or minus. But since this is a length of a side, we know we can reject that negative right off the bat. So I'll do second radical and grab that last answer, or you could do second negative there. Write out your entire decimal. I'll let you guys write that out. And then round to the nearest tenth, it says. Okay, so that would be 26.1. So that's our 26.1 pounds this was in. And that's the first part. Now it says, starting here, using this answer, find the measure of the acute angle between the second applied force, so the second applied force, and the resultant. So the resultant is your diagonal. So the second applied force, again, trace them, and the resultant, trace it. So I'm looking for that. Now I've already used X, so you need to use a different letter. So you could use Y, you could use any letter. I'm going to use A here. So I'm looking for side A, but I can use this, that now that I have this angle right here is 20, or side rather, is 26.1, I can use that to find A, it says. So to do that, now I'm looking at that yellow triangle again. I do have a side across from a given angle now. I have angle 25 across from side 26.1. So now for part B here, I can use law of sines. We'll call this part B. I'll label it B. So now pause the video, set up your law of sines. You can use that rounded value of 26.1 and solve for A. And you know what, actually you might want to call it capital A since it is an angle, but it doesn't matter. All right, and you should have two angles and you're going to have to check both of them to see how many possible answers you have. All right, so you should have had 30.2 over sine of A equals 26.1 over sine of 25 for your setup. Cross multiply, you get sine of A is 0.4890065,711. Do inverse sine to find angle A. And you should get 29. And on your papers, you should have all of that work written out. And here, sine was equal to a positive value, so you would have found two different angles for A. So since it was positive, it could be in quadrant 2, so 180 minus that entire decimal would have given you 150.7246927. And there we'd say, okay, well, is that possible? So if I put that in for angle A right here, I'd have to add that to 25 degrees. And that one will not work here also because we've got the measure of an acute angle. So I'll show you here. So we would take our 150.7246927 plus our 25, and we do get under 180 degrees. But if I were to take that angle, and it says here, find the measure of the acute angle between those two forces, the resultant and the second applied force, then this would not be acute. So we'd have to reject because it's not acute. And our final answer then would be, to the nearest degree, 29. Oh boy, 29 degrees. All right, and lastly, number 5. So pause the video here, write down what you need to, and I want you to try to draw a picture and label it, and then solve it if you can. There's one little trick here that I'll give you a hint on if you get stuck. All right, so I see forces, so I'm going to draw my parallelogram. So I've got 12 newtons and another force. So let's call that other force X. Act at an angle of 57 degrees to each other. So the two forces, these two forces right here, the 12 and the X, form this angle. So that's going to be your 57 degree angle. The resultant, remember, goes bottom left to top right, is the diagonal, forms a 35 degree angle with the 12 Newton force. So read that again. The resultant forms a 35 degree angle with the 12 Newton force. So this angle up here is 35, which means this angle down here must be 22 if the entire angle is 57 degrees. Okay, now I want to find the magnitude of the other force. So this is X. So far I know my alt interior angles. This is 22 up here. This one's 35. This side over here, opposite sides are congruent, so that's 12. This is X. I'm going to focus on one triangle, so I'm looking at this bottom triangle. And there's one other thing that will help you here to solve that, and that is in a parallelogram, your consecutive angles are supplementary. So if I know this angle's 57, I know these two consecutive angles in the parallelogram add to 180 degrees. So consecutive angles in a parallelogram add to 180 degrees. So I can take 180 minus my 57, which gives me 123. So this angle over here is 123. And that should really help you now to set this up. So it looks like because we're trying to find the magnitude of our other force. So we have a side across from a given angle, and then you could actually use here law of sines. And actually you don't really need that 123, but it will help you in some other problems as well. So important to know that here for the future. So in this one, you can set up your law of sines. So go ahead, pause the video and set that up, solve it, and round to the nearest Newton. All right, so you should have gotten here that X is approximately 18 newtons, and you should have all of that work on your paper when I look at your notes. And that is it for today. If you have any questions, let me know, and I hope to see you guys soon. Bye out.